Hello everyone and welcome to this data scenario where we are going to build an e-commerce product recommendation system using RAG. So in this project, you're going to act like a mid-level AI engineer hired by ShopVista, a leading e-commerce platform offering a wide range of products from electronics to home goods. The company aims to improve its product recommendation system by developing a context-driven search feature that delivers personalized suggestions based on users' search phrases. ShopVista has provided a dataset containing product titles, descriptions, and identifiers of thousands of items. Your task as an AI engineer is to use a RAG system and OpenAI's models to build a recommendation system that understands user search inputs and generates highly relevant product suggestions. The goal is to enhance the shopping experience by making recommendations more intuitive and tailored to each user's specific needs. Amazing, so let's get started. In the next task, we are going to set up our project environment. So see you in the next task. Hello everyone and welcome to the first task. In this task, we will set up the Google Colab environment, install and import the necessary Python modules, and configure the OpenAI API. So let's get started. Here is the Google Colab environment. If you haven't logged into your Google account yet, feel free to pause the video and do so. Amazing. So now let's get started. The first thing that we need to do is to upload the project notebook into our Google Colab environment. To do this, I'm gonna go ahead and click on File. I'm gonna click on Upload Notebook. I'm gonna go ahead and click on Browse. On my desktop, I have the project resource files. I'm gonna open it and have a look at it. So as you can see, we have different directories in these project resource files that we are going to talk about them shortly. But the main notebook that we are going to work on is called the notebook. So I'm going to click on it and open it. I wait until it is uploaded on the Google Colab environment. All right, so here is the notebook that we are going to work on during this project. As you can see, this notebook is divided into 5 different tasks that we will need to go through one by one in order to complete this course. Now, if I go ahead and expand task 1, I can see that I have some code blocks, some comments, some placeholders to write code in order to complete each of the tasks within this course. Amazing. So now the first thing that we need to do is to install the needed modules. To do that, we are going to install OpenAI version 1.16.2 and Python-.env module. We are going to talk about this module in a minute. So let's go ahead and run this block. We wait until all the modules are installed. I have already installed them, so that's why it says requirement already satisfied. In the next code block, we are going to import the needed modules and set up the OpenAI API. So we are going to use Pandas, NumPy, OS, OpenAI, and .env. We also have imported cosine similarity from sklearn matrix.pairwise. That is going to help us to compare numerical vectors. We are going to talk about it in the later tasks. Now, the next thing that we need to do is to set up the OpenAI API. Amazing. Now, let's go ahead and start with setting up the OpenAI API. The first thing that we need to do is to create a .env file to store the OpenAI API key. It is always recommended to store your API keys in a .env file as it helps to separate sensitive information from the code base. And this is basically improving the overall security of your project. In here, we can see that we have different folders and files that we are going to use for this project. We have the challenge task folder, the practice task folder, we have an API key.env file, we have a dataset called products dataset. This is the main dataset that we are going to use for this project. And of course, we have the notebook. So to set up the OpenAI API, we need to configure this API key.env file. I'm going to go ahead and double click to open it. So as you can see, this file has 2 different variables. We have the API key and the organizational ID. If you guys are using your personal OpenAI account, you don't need an organization ID. For the API key though, you need to go ahead and paste your OpenAI API key here in between these two double quotations. I'm gonna go ahead and configure this file for my OpenAI. Please pause the video and configure your OpenAI API key here. Once you are done, save it and close it. Let's go back to the Google Colab environment. Now, what we need to do is to upload the API key.env file that we prepared to our Google Colab environment. I'm gonna go ahead and click on File section. I'm clicking on Upload. I am going to the project resource files and click on the API key.env file that we just prepared. I'm gonna open it and I'm gonna get a warning, ensure that your files are saved elsewhere. These runtime files will be deleted when this runtime is terminated. So if your runtime on Google Colab terminated, you have to make sure that you re-upload the API key.env file again. So I'm gonna go ahead and click on OK. So in this code block, first we are going to import all of the needed modules. Then we are going to load the API key from the .env file that we just uploaded on our Google Colab environment. I'm gonna use os.getEnv to get the API key variable, and if you need it, you can also get the organizational ID in here. Then we can create an instance of the OpenAI client with the provided API key and organization ID. All I have to say is to say client is going to be equal to the OpenAI. I'm gonna call this and I'm passing in the organizational ID and the API key. If you guys don't have an organizational ID, all you have to do is to just comment this line of code. And I'm just going to go ahead and run this code block. And in this way, we are going to have our OpenAI client ready for our project. Amazing. So that was it for this task. In this task, we set up the project environment. In the next task, we are going to have a look at our knowledge base. So see you in the next task. Hello, everyone, and welcome back. As you know, ShopVista has provided us a dataset containing the information about their products. In this task, we will load the product dataset and have a look at it. We will then generate the text embedding vectors required for our RAG system and ultimately for our product recommendation system. But before we do this, let me show you how we are going to create this recommendation system. You see, in our system, everything begins with a user prompt. Imagine a user searching for a specific product, something like, I'm looking for leather boots for my girlfriend. On one side, we have our user request, and on the other, a large product dataset. Now, the goal is to provide product recommendations based on that prompt. A straightforward approach would be to pass the entire dataset and the user's request to a large language model and ask it to generate recommendations. However, since we have thousands of products in the dataset, this approach would not only be expensive, but could also exceed the LLM's context limit. This is where a RAG system comes in. Instead of sending the entire dataset to the LLM, we first search for the most relevant products by using text embedding and vector similarity. This narrows down the dataset to a small relevant subset. We then craft a context-rich prompt that includes the top 5 most similar products based on the user's request. With this tailored prompt, the LLM can generate accurate and personalized recommendations without overwhelming the model or exceeding limits. So in this task, we'll start by preparing our dataset and creating text embedding vectors. These embedding vectors will be used for our context-based search and ultimately help us build a more efficient recommender system. So let's dive in. So now let's go ahead and expand task 2. The first thing that I need to do is to load the products dataset. To do this, let's first upload our products dataset to our Google Colab environment. I'm going to go ahead and open the file section. I'm clicking on the upload button and I'm going to select product dataset from the project resource files. I wait until the product dataset is uploaded. So now that I have this, I can go ahead and write some code. So I'm going to go ahead and create a variable called products data. And I'm going to use pandas read_CSV and I'm passing in the path to the products data. Now let's go ahead and have a look at the project resource files for this course. And I just paste it in here. Then let's go have a look at this data. I'm gonna run this. Let's go ahead and close the file section. Now you can see that in our products data set, we have a product ID that is a unique identifier for each of the products we have. We have a product title and a product description. Now, what I want to do is to create a text embedding vector for each of the products that we have. But before I do this, I want to combine product title and product description column to include more information about each product within our text embedding vectors. Now, let's go ahead and combine product title and description. I'm going to go ahead and create a new column in the products data frame. I'm going to call it item. Then what I'm going to do is to say products underline data, the column title, plus products underline data column description. Let's go have a look at the products data again. Now I can see that I have this new column in here, right? Now the next thing that we want to do is to create the text embedding vectors. To do this, we need to use OpenAI text embedding model. So text embedding models are a type of natural language processing technique used to represent words, phrases, or entire documents as numerical vectors in a high-dimensional space. Basically, the text embedding model gets a piece of text and converts it into a vector of numerical values. These vectors capture the contextual meaning of the text. So if you have two sentences and you want to know how similar they are in terms of the meaning, you can use the text embedding model to convert these two texts into numerical vectors, and by comparing these numerical vectors, you can have an understanding of how similar or how different these two sentences are. Now let's go ahead and use OpenAI text embedding model to create text embedding vectors out of this column. To do this, I'm going to go ahead and use my variable client. This is the OpenAI client. I can say client.embeddings.create. So in here, I just need to specify some parameter. The first thing is the model name, the name of the model from OpenAI that we want to use. For this, I'm going to go ahead with text-embedding-3-small. If you want to explore other text embedding models from OpenAI, have a look at their website. The next thing that I want to specify here is the input, which is a list of the text that I want to generate the text embedding for. Let's say for now we have the word apple. And the third parameter, which is a very important parameter, is called dimensions. For now, I just want to put it as 3. So this parameter is specifying the number of dimensions of the generated text embedding vectors. Basically, as this value gets higher, that means that it includes more information about the word apple. But of course, it is gonna get more expensive. Now let's go ahead and run this to have a look at the response. So we have received a create embedding response object. Within this object, I have a list called data that contains some embedding objects, and there is one object in here. Within the embedding object, I have the embedding vector containing 3 dimensions describing the word apple. Now, if I have more text in here, like orange, I rerun this again, and I can see that the data property has 2 different embedding objects in it, right? Now, the thing is, I can also increase the number of dimensions, let's say 5. I rerun this, and I can see that each embedding vector contains 5 different numerical values. So this embedding vector is describing the word apple, and this embedding vector describing the word orange. Now, what we want to do is to generate the text embedding vectors of all of these elements within the item column. To do this, I'm gonna replace this with products data.item. This is the column, and then I can convert it into a list. And for each embedding vector, I want to have 512 dimensions. Basically, each of the products that we have is going to be described by 512 numerical values. Now, I will store this into a variable called response. Now, what I want to do is to loop through the data property and find all of the embedding vectors in the response. To do this, I'm going to use list comprehension in Python. I say d.embedding for d in response.data, right? So I'm going to go to the response.data, this one. I grab this list and I start looping through. For each item, I return this parameter, d.embedding. I'm going to create a new variable called vector embeddings. Now I can store this vector embeddings variable within a new column in my data frame. So products data, and then I create a new column. I'm going to call it embedding vector, and then I just pass in vector embeddings variable in here. Let's have a look at our products data. So I'm going to run this. This might take some time because for each embedding vector, we are generating 512 dimensions. Amazing. So now I have a new column called embedding vector for each of the items within our products dataset. Amazing. So that was it for this task. In this task, we prepared our knowledge base for the RAG system. In the next task, we are going to retrieve relevant items based on a user prompt. So see you in the next task. Hello everyone and welcome back. In this task, we will use the embedding vectors to retrieve relevant items based on the user search phrase. But before we start, let me show you how we are going to do this. So in the previous task, we created embedding vectors out of the product's description and titles that we have. Now for each of the products in our dataset, we have a vector embedding with 512 dimensions. Now, if we have a user prompt, we can use the same text embedding model from OpenAI to create a vector embedding with 512 dimension out of the user prompt. Then in our 512 dimensional space, we can compare the embedding vector of the user prompt with all the embedding vectors in our dataset using a measure called cosine similarity. And then we can find the 5 most similar products to the user prompt. Cosine similarity calculates the angle between two vectors. The smaller the angle, the more similar the vectors are. This is especially useful in high dimensional spaces because it focuses on the direction of the vectors rather than their magnitude. Of course, there are other measures that we could use for this purpose, but for our use case, cosine similarity is ideal because we are interested in the semantic similarity between the user's prompt and our dataset entries, regardless of their absolute values or lengths. Cosine similarity helps us capture that meaning effectively. So now let's get back to the notebook and get started. All right, so I'm gonna go ahead and expand task 3. In here, I'm gonna have a user prompt. I'm remodeling my bathroom and need a stylish white sink with a faucet included. Now, make sure that you run this block because we need this variable. The next thing that we need to do is to find the embedding vector of the user prompt. To do this, I'm gonna create a variable called response, and I say client.embeddings create, and then in here as my input, I'm gonna have a list, and inside of this list, I'm gonna have the user prompt, right? The model is going to be text embedding 3 small. And of course, the number of dimensions is going to be equal to the number of dimensions of my embedding vectors in my data set, which is going to be 512. I'm going to create a variable. I'm going to call it user prompt vector. And then I'm going to use a list comprehension. I say d.embedding for d in response.data, right? And I'm just gonna go ahead and print out the user prompt vector, and let's just have a look at the first 10 values. And here we go, we have our user prompt embedding vector. The next thing is to find the similar products to the user prompt. So to do this, I am going to use the cosine similarity that we have imported in the first task from sklearn. So let's go ahead and have a look at our products data.embedding vector. So I'm going to have a look at the column that I have stored all the embedding vectors of 2,000 different products I have. Now we need to convert each of these embedding vectors into a NumPy array. The reason is that the cosine similarity from sklearn only accepts NumPy arrays. Now to do this, here I can say .values. This will return a list of lists that each list is basically our embedding vectors. Now, what I can do here is that I'm just going to cut this. I can define a list comprehension and say NP array for each of the vectors that I have for vec inside of products.dataEmbeddingVector.values. And I'm going to go ahead and store it into a new variable, product values. Now the text embeddings are converted into NumPy array. Let's go ahead and do the same thing with the user prompt. To convert the user prompt vector into a NumPy array, I can just go ahead, make a copy of it. Let's be lazy a bit. np.array, and then I'm just passing it in here. So in this way, I have both my products embedding vectors and the user prompt embedding vector converted into a NumPy array. Actually, let's call this product vectors. Right? Now, to compare my user prompt vector to all of the other vectors that I have in my products dataset, all I need to do is to use the cosine underline similarity method that I have imported from sklearn. This will get the product vectors and the user prompt vector. And it is going to find the similarity measure of my user prompt vector to every of the vectors that I have in my product vectors. If I run this, I can see that this will return a matrix. And this is an array of lists with only one value. And this value is the similarity measure that we can use to compare our user prompt with the first product vector, then the second, then the third, and so on and so forth. I'm going to create a new variable. I'm going to call it similarity matrix. And what I'm going to do that is actually really helpful is to extract all of these values. And I say similarity values. And I'm going to loop through all of these lists in my similarity matrix and get the first element, which is only this measure. So I say v.0 for v in similarity matrix. Let's have a look at our similarity values. Now in here I have a list of numerical values that are the similarity measure between the user prompt vector and every and each of the product vectors that I have. And if we check the length of this similarity values, it should be 2000. And now let's go ahead and create a new column in our products data. And I'm going to call it similarity measure. And I'm just going to put the similarity values in here. Let's have a look at my data frame again. I'm going to run this. And in here, I can see that I have a similarity measure that shows the similarity between this product and what the user is searching for. Now let's go ahead and sort the rows within my data frame by the similarity measure. And it is going to be ascending, false, and also I want it to happen in place. So in place, true. I'm going to run this, and let's have a look at the data frame again. And I can see that in the first row, I have a product that it has 60% similarity with what the user is looking for. And the title is Contour Oval Drop-in Bathroom Sink in white. If you remember, our user is also looking for a stylish white sink with faucet included. Amazing, so that was it for this task. In this task, we retrieved the relevant items based on a user prompt. In the next task, we are going to use these items to craft a context-rich prompt. So see you in the next task. Hello everyone, and welcome to this practice task. This task is optional and its purpose is to assess your understanding. You have been hired by a 40-year-old news company called FF News. They have provided you with a list of their news headlines from March 2004. They are looking for 10 headlines from their archive specifically related to climate change and global warming. As an AI engineer, your task is to use the OpenAI text embedding model to identify 10 headlines about climate change and global warming from their archive. To get started with this practice task, go to the project resource files and open the practice task folder. Upload the notebook file, practice task notebook, to your Google Colab environment. Follow the instructions in the notebook to complete the practice task. Feel free to pause the video to work on the task, and once finished, resume to see the solutions. Amazing, so I am back with the solutions. In the first code block, we import all of the necessary modules and we configure the OpenAI API. After that, we can see a list of news headlines from FF News. So the first thing that we need to do is to use OpenAI's text embedding model to generate the embedding vectors with 256 dimensions for each of the headlines. After we do this, we are going to extract these vectors. I'm going to use a list comprehension to do that. So now I have a list of vectors with 256 dimension. After that, we can use the embedding model to generate a 256 dimensional embedding vector related to the phrase, our search phrase, global warming and climate change. Then extract the embedding vector from the OpenAI response and store it into a variable called search vector. And this is how the search phrase vector looks like. After that, I'm going to create a data frame that has two columns, vectors and headlines. Then I'm going to go ahead and create another column called similarity score. And I am going to apply this lambda that gets a vector and calculate the cosine similarity between the vector and the search phrase vector. And it returns the cosine similarity between those two vectors. This line of code is basically looping through the vectors column and calculate the cosine similarity between each vector with the search phrase vector, and at the end put it in a new column. Now that you have the similarity score in this data frame, all you have to do is to actually sort the values by the similarity score, ascending equal to false, get the first 10 and get all the headlines. And then you can loop through and print them out. In this way, we can get all of the headlines that are related to global warming and climate change. Hello everyone and welcome back. In the previous task, we retrieved the relevant items within our database based on a user prompt. In this task, we're going to use the retrieve products to craft a context-rich prompt for our LLM request. So let's get started. So I'm going to go ahead and expand task 4. In the previous task, if you remember, we calculated the similarity measure and we sorted our products data based on the similarity measure in descending order. What we need to do is to find the top 10 similar items to the user prompt. I'm going to create a variable and I'm going to call it top 10 items. And if I say products underline data.head 10 and have a look at it, I'm going to have the top 10 items that are similar to what the user is searching for. Now let's go ahead and combine the information about the top 10 similar products to our user prompt. We're going to use the column item. To do this, I'm going to go ahead and create a variable called combined text. And I'm going to use \n as the delimiter, and I am going to join everything that is in top 10 items item column. Now let's go ahead and print out the combined text. I'm going to run the block, and I can see that I have a text that contains the information of the top 10 items. Now let's go ahead and craft our prompt. Now to create our prompt, we are going to use the information related to these top 10 items and put it in the context of the prompt. I'm going to go ahead and create a variable called prompt, and I'm creating a multi-line string, and I start to write. So I say, I want you to act as a customer service agent. We have the following products. And then here, I'm just going to go ahead and pass in the combined text variable. Don't forget to add the format string in here. So basically, in the context of this prompt, we are going to have the top 10 similar items information. What I'm going to say is that based on the user prompt and the products listed above, please provide 2 products as recommendations. Here is the user prompt, and then I can just basically pass in the user prompt text that we have. Now let's go ahead and print out the prompt variable. I'm going to run this, and as you can see, I have a prompt that is asking a large language model to give us 2 products recommendations based on these products. And we also passed the user prompt text in here. So that was it for this task. In this task, we used the top 10 similar items to craft a context-rich prompt for our LLM. In the next task, we are going to prompt the LLM to generate the product recommendations. So see you in the next task. Hello everyone, and welcome back. In this task, we will prompt the LLM using the context-rich prompt we created to generate user-friendly product recommendations based on the user search phrase. So to create a recommendation system for ShopVista, so far we searched for the relevant products based on a user prompt. Then we found the relevant products and we used them to craft a context-rich prompt. Now in this step, we are going to use this context-rich prompt to ask the OpenAI large language model to give us the product recommendations. So let's get started. So I'm going to go ahead and expand task 5. In here, I am going to use our client to chat with the OpenAI. So chat.completions.create. So in this way, I can send a prompt and get response from the OpenAI. I'm going to use the model GPT-4o, and then here I will specify the messages. In my messages, I'm going to have only one user message. So the role is going to be user, and the content of this message is going to be the prompt that we created in the previous task. And then after this, I can also specify a max tokens. Just put a comma here. The max token I want to use is 1,200, and we are all set. Now, if I run this, I will receive a chat completion object that within I have an ID, some choices, and each of the choice objects has a message that contains the content that we are looking for, which is the answer to our prompt. Now, what I'm going to do here is to actually create a variable called response. Going down here, let's extract the content that we are looking for. So I'm going to create a variable called content. And I say response, go to the choices, get the first one, go to the message object, and get the content. I can go ahead and print out the content. I'm going to run this. And here is our product recommendations. I'm going to go ahead and print out the user prompt in here as well. So user says user prompt, and our agent is going to answer the content. So I'm going to run this. So the user asks, I'm looking for remodeling my bathroom and need a stylish white sink with a faucet included. And our AI agent says, based on your requirement for a stylish white sink with faucet included, I recommend the following products. So this product, which is the modern in white ceramic rectangular vessel sink with faucet included. The second one is 16 gauge sinks, vessel sink in white with faucet. Amazing. So now we have our product recommendation system based on a user prompt. Now let's go ahead and try out another user prompt. So let's go to the third task. In here, I am just gonna remove this and paste my new user prompt here. Do you have a round silicon lead set for food storage? I'm gonna go ahead and click on run after to basically run all of the cells again. So we find the similarity measures, similar products, and here we go. We're gonna have our product recommendation here. User says, do you have a round silicon lead set for food storage? AI answers, certainly, based on your inquiry about a round silicon lead set for food storage, I recommend the following products. Silicon navy round lead set of 3, and essential 1810 stainless steel blue lid lunch box. Amazing. So that was it for this task. In this task, we completed our product recommendation system for ShopVista. In the next task, we have a challenge for you guys. So see you in the next task. Hello everyone, and welcome to this challenge task. This task is optional and its purpose is to assess your understanding. So you have been hired by a 40-year-old news company called FF News. They have provided a data set containing headlines, their vector embeddings, and similarity scores to the phrase climate change and global warming. As an AI engineer, your task is to use the OpenAI GPT-4 model to generate a short article based on the top 3 most similar headlines to climate change and global warming. To get started with this challenge task, go to the project resource files and open the challenge task folder. Upload the notebook file challenge task notebook to your Google Colab environment. Upload the challenge task data.csv file to your Google Colab environment, and then follow the instructions in the notebook to complete the challenge task. Feel free to pause the video and complete the challenge. Resume to see the solutions. Amazing. So I am back with the solutions. To get started, we need to install the needed modules and import them. After that, we are going to load the challenge task dataset.csv. Within this dataset, we have vectors, headlines, and similarity scores. The next thing we need to do is to sort the dataset based on similarity score in descending order. And we can easily get the top 10 headlines related to climate change and global warming by saying data.head3.headlines. And then in the next part, we are going to craft a prompt to generate an article based on the top 3 similar headlines. The prompt says, act like a global warming reporter. Write a short article based on the following headlines. And then we basically pass in the top 3 headlines related to global warming in our archive. And then to send this prompt to the OpenAI, all we'll need to do is to use client.chat.completion, and then we're gonna call create. We pass the model name and we pass the messages. We put the prompt inside the content. We put the temperature to 0.7 to make things a bit undeterministic, and in this way we can return the article. And here is the article that we could generate. Congratulations in completing this data scenario. I hope you guys have enjoyed it. See you next time.